Hello, welcome back. So now I will be continuing my linked list series. So the next problem on the series is called reorder list. So let's go through the problem statement once. What it says is, given a single linked list L which has nodes L0, L1 ln. So here we can see the nodes L0, L1, Ln-1 to Ln. So now we have to reorder this list in such a way that the first node and the last node will be together, then the second node and the second last node will be together, and so on, like L0 ln L, L1 ln-1. So here it clearly says you may not modify the values of the list nodes, only nodes itself may be changed. So it doesn't mean that we just swap the values and our work is done. We have to change the pointers itself, like the pointer of the first node should be the next pointer of the first node should be pointing to the last node. So we have to change the next pointers, not just the values. So the examples are pretty straightforward, like 1 4 will be together, and then 2 3, and here also 1 5, here 1 5, and 2 4, here 2 4, and 3 is remaining, so 3. So this is the problem. And here also in the function description we can see, do not return anything, we just have to do it in place just by changing the pointers. So now let's go to the whiteboard and let's see how we can do this thing.
We will be given a linked list like this one, and we have to convert it to a linked list like this one. Here we can clearly see again that the first node is connected to the last node like this, then second last with second with second last, and third is third. Okay, so we have to connect or reorder this first input list as this output list. So how can we do that? So one simple way of doing it is like we just change the values of these nodes. Like we just uh, take this 5 over here and 2 over there, and we change this value of 3 to 2, or we just take one stack and we take the values from here to here in the stack, and we just keep on changing the node values. So that will work. So that is a simple way of doing it. But here in the question it explicitly mentions that we don't have to just change the values, we have to change this links also. So this 1 to 5 connection means we are actually changing this next link to like this, and this 2 to 3 means, sorry, this 5 to 2 means that we are changing here null to here, none to here. So this is the way we have to change the links. So that's why the value swapping thing will not work over here. So let me write down the linked list once again over here, and let's see how we can do this thing. So it is 1 2 3 4 and 5. Okay, so um, let's just think for a moment how we can do this. So okay, so we can do one thing, like we can find out the middle element of this linked list. So what will be the middle element? The middle element will be this one, right? So now let's say we detach this linked list into two separate linked lists and start merging them together. So how this two linked list will be look like if we just separate them from the middle. So one linked list will look like 1 2, another will look like 3 4 5. We just delete this pointer and break them into two linked list. So now we have two separate linked list, and we just have to now reverse the second linked list. So we just have to now reverse this second linked list. So after reversal, what this second linked list will look like, it will be 5 4 and 3. And if we just write these two once again, so it will be the first linked list, let us just call as like L1, it will be 1 2, and L2 will be 5 4 and 3. Now we are seeing a pattern, like here 1 is connected with 5, here we can see 1 is connected with 5, we just have to connect them. 2 is connected with 4, so we just have to connect them, and 3 is left alone, so 3 is here. So now if we just merge these two linked lists, then our job is done. So now we have to check how to merge this linked list. So the merging part should not be very difficult. We just do what we first, let's say this is L1 and this is L2. We take two pointers. So we now uh, take one variable where we store the next value of L1. So let's call it next, where we store L1 dot next. So in L1 dot next, we already stored the next value of L1. Now we do what? L1 dot next, we connect it with L2. So this next pointer is now connected with L2. So like this. Okay, so after connecting this, we just have to increase or move forward the pointer. So now the L1 becomes here. So this L2 becomes L1. So here L1 comes and L2 becomes this node. So L1 is going to be L2 and L2 is going to be this next. So L2. Once again we do this same thing. So L1 dot next is stored in here and L1 dot next is connected to this two. So by this way we just connect all the nodes. So we get this sort of merged linked list, and if we just straighten this thing up, we get our desired answer, which is 1 5 2 4 and 3. So this is our simple solution. So what are the three steps we need to do? First step is middle. We have to find the middle of the linked list. Second step is break from middle. Break from middle. After breaking into two linked lists, what is the third step? We reverse. We reverse from middle. After reversal, the fourth and last step is we have to merge. We have to merge the both linked list. So what is the time complexity over here of this algorithm? We just doing linear time traversal. So that's why order of n or big O of n is time complexity and space complexity is big O of 1, because we are not using any extra space. So that is how our algorithm pans out. So let's go to the now code editor and let's see how we can code this algorithm.
Now let's code it, whatever I have explained in the whiteboard. So first of all, before doing anything, we have to check if the linked list is empty or having only one node or not. If it's having one node or it's empty, we don't have to do anything. We just simply return, because there is no point of just doing reorder because it's having only one node. So first condition will be if head equals to none or head dot next. Head dot next means that only one node is present. That means we just simply return. So after that, the whatever was the first step in our explanation in the whiteboard, we have to find the middle. So finding middle, we need two pointers, slow pointer and fast pointer, and also we need to keep track of whatever is the point which is immediate previous of the middle point, because we have to detach it, right? So let's say for this example, if this is the mid, so for detachment we have to know this point, right? Because we have to make what, this, let's say call this previous. So previous dot next has to be null or none. So that is the only way we can just detach this linked list. So that's why we have to keep track of previous also. So we will be keeping track of three pointer. One is previous, one is fast, and one is, let's say, slow. So for previous we initialize with none, and fast and slow will be head. So after that we know how to find the middle element of any linked list. So loop will be while fast dot next is not none, we will be looping through. So first we will be keeping track of previous. So at first previous will be slow and slow will be slow dot next. So basic stuff like how we find out the middle of linked list, and fast will be incremented twice. And if you don't know exactly how to find out the middle of the linked list, you can go through any tutorial online. It is a simple process. So after that we know that the middle point is lying in the slow pointer and previous pointer having the previous element of middle. So for detachment we have to do what, we have to make previous dot next is equals to none. So that means this link is broken and we have two separate linked list. Okay. So now okay, so now we have two separate linked list. One linked list is, let's say, L1, that is starting at head until this element. So the start element is head, and another L2. So what is L2? L2, first we have to reverse the second linked list, right? So let me just define a function over here called reverse. Def reverse, and the first argument as usual is self, another is node. So again, if you don't know how to reverse a linked list, please go through any tutorial out there. So I will be just quickly going through and write the code of linked list reversal. So first of all, if the node is none or there is only one node, so node dot next equals to none, that means we just simply have to return node. Or else we as usual will take three pointers, one is current, one is previous, and one is next. And the current pointer should be initialized with head and other two pointers will be none. It doesn't matter what you initialize them with, you can initialize with head also. So while current is not none, we keep track of the next pointer of current because we will be overriding it in the next step, so that's why we keep track of it. Now the current dot next is previous at each step, and the previous now becomes current and the current becomes next. After that, our head of the reverse linked list will be always be in this previous pointer. So if this part of the code is not clear to you, I again say please follow any tutorial out there of linked list reversal. Okay, so after returning this previous pointer, we have the head node of the reverse linked list. So we have to store it in L2 because our L2 is the second linked list reversal's head. So that's why we just have to call this reverse function. Let me just copy from here. Okay, and we call it from here and we pass slow because slow was the middle element, like here. So after this we have two linked lists. So now again the last step remains is we have to merge them. So let's call one merge function which we are going to define right now, L1 and L2. After merging, our job is done, we don't have to return anything, so we just have to do what, define this merge function. Let's define it. Merge, the first argument is as usual self, then L1, then L2. Okay, so while L2 is not none, what are the steps I have told in the whiteboard? First, we will take a variable next or nxt whatever to keep track of what is the next element of L1, because we will be doing what, we will be making the next of L1 to point to L2 in each step, and after that we have to just move forward. And how we are moving forward, we are making L1 is pointing to L2, so L1 is now L2 and L2 is that next nxt. After this thing our linked list will be merged. So we have done all the four steps which we have mentioned in the whiteboard. So after this our code should work. Let's run it. Okay, here I have made one typing mistake. Okay, head is not defined. There is one mistake I guess. Okay, so here the argument was node, sorry for that, and it's accepted. So let's just submit it and see. Okay, we are getting an error where head dot next is null. Whatever is the error. Okay, okay, sorry, here it would be or. So because right, if there is no head there should not be any head dot next. So now it works. So because of the hurry I just made some mistakes. So this is how you have to solve this problem. The algorithm is clear I guess because I have made it very clear on the whiteboard. There are only four steps. One step is you have to find the middle, detach them, reverse the second part and merge them together, we get the reordered linked list. So thank you for watching. I hope you understood this problem, and if you liked it, Please make sure that you like this video and subscribe to my channel for more. Thank you.